writing this parametric equation in terms of just x and y is very different from the examples I showed you in class, mainly because I can't simply isolate the t value. That's not going to work very well. What I can do, though, is recognize that cosine and sine have lots of great identities attached to them, and we have the good fortune, and we'll always have the good fortune of having this coefficient in front of each being the same. Now, the identity that's going to help us a lot is the identity that the cosine squared of theta plus sine squared of theta, no matter what the value of theta is, always equals 1, no matter what. The problem is I don't have just a cosine, it's just a sine. I have 3 cosine and I have 3 sine. So what I'll do instead is think about this as an entire thing. What happens if I take this entire expression and I square it? And if I take this entire expression and I square that? Can I use information about this and this to take this further? Well, from basic algebra we know that 3 cosine t, if I square that entire expression, I get a 9 cosine squared t, and likewise I'll get a 9 sine squared t. These have a common factor of 9 because these matched, and I can factor that 9 out. And we know that this equals 1. So that means that this whole thing equals 9. So if this guy equals this guy, and this guy equals this guy, and that equals 9, really what I know is this whole thing equals 9. Now, how does that help us figure out how to write this in terms of x and y? Well, 3 cosine t is the same thing as x, so I can replace this with an x. And 3 sine t is the same thing as y, I can replace that with a y. And it ends up being x squared plus y squared equals 9, which you might recognize as the equation of a circle centered at the origin whose radius is 3. Then again, you might not recognize it as that. I'm not sure. Now the first time you see something like that, it seems like algebraic sorcery, and you're like, how would I ever think of that? But this whole idea of like taking a circle and writing it in these with parameters like this becomes a very common thing down the road. And like the 10th time you see it, you're like, oh yeah, it's that thing. So this first time might seem crazy, but basically if you got a cosine of t and a sine t in your parametric equation, you're going to have to think about these identities to figure out what the heck's going on. Sorry I didn't cover that in class. I hope this makes sense, and good luck.